Okay guys, so we come back to food components, and this should be one of the several topics that are going to be end is the final part of food components. So we come to food lipids. These are all mostly non-polar. We know that very basic structures that you have already learned in school, maybe. It is known as triacylglycerols or triglycerides. So to be brief, to be simple, we just call it TGs. So TGs are triesters of glycerol and fatty acids. Well, the figures like the E just now. Glycerol, simple organic molecules, sometimes called glycerin. You can buy this in the pharmacy. 3 carbon molecule containing 3 alcohol groups. So 1 glycerol, 3 fatty acids. Fatty acids are organic molecules, contain chains of carbon bound to hydrogen. Plus we have an acid at one end and a methyl group at the other. And then we know there is ester bonds that hold the fatty acid to glycerol, joining the OH groups of glycerol to the COOH groups of fatty acids with the loss of water. Okay, so that is called the head, the head of the glycerol, and then it has this 1, 2, 3 fatty acid tails. But it's not yet formed TGs, so now we have to form TGs, glycerol plus 3 fatty acids. So we form TG here, and we liberate 3 water molecules, and we form that ester bonds. Okay, as mentioned in any books, they mention this particular hydrocarbon chain. They say it's a carbon skeleton bound to hydrogen atoms. Lots of hydrogen here, okay. What else we need to know about fatty acids? Basically, we have to know about the saturated versus unsaturated fats. So fats and oils are mixtures of fatty acids differing in chain length and degree of unsaturations. The difference between them is, you want to be simple about it, easy to remember, is saturated does not contain any carbon to carbon double bonds, so they should be highlighted. In contrast, unsaturated fatty acids contain carbon to carbon double bonds. It can be mono unsaturated, it can be poly unsaturated, and the fact that they have whether the fats are made up from saturated or unsaturated fatty acid is very important in food technology, because that will determine the physical properties of that particular fats or oils. Okay, to make things clearer, we use an example. Saturated fatty acid versus unsaturated fatty acids. So you look first at the unsaturated fatty acid here. So all the carbon atoms are fully bound to the hydrogen atoms, so you call it saturated because of that, and all the bonds between carbon atoms are single, and the hydrocarbon chain has a straight shape. So this fat that is made entirely of saturated fatty acids is what we call saturated fat. If this fat is made entirely of saturated fatty acid, we call this fat saturated fat. Because their tails are all straight, they are said to be more compact and tend to be solid at room temperature. Okay. In contrast, if in the case of unsaturated fatty acid here, the hydrocarbon chain has fewer hydrogens. Now it has less hydrogen here, and some carbon atoms bind to each other via double bond like this one. this double bond causing bending. The carbon chain slightly bended, creating gaps. There's a gap here. So the gap between molecules, making them less compact and tend to be liquid at room temperature. So by having a different, it make a lot of difference if your fat is made entirely of saturated or unsaturated fatty acid. The physical state of the products, yeah, whether it is solid or liquid. These are examples of some fatty acids, whether it is saturated or unsaturated. Yeah, so you can see like butyric C4 has very low carbon versus linoleic polyunsaturated. So you have you learn organic chemistry. This is notation to denote, to indicate whether it has any double bond and how many carbons. Yeah. So another properties of fats affected their behavior due to the whether they are cis or trans fats, and these are all only related to unsaturated fatty acids. Yeah. There are two possible configuration. That particular unsaturated fatty acid can be cis or it can be trans. If it is cis, I mean the hydrogen atoms bonding to the double bond of carbon are located on the same side. If it is trans, the hydrogen atoms attached to the carbon atoms of the double bonds are opposite each other. You can't imagine this unless you look at the figures. I'll show you the figures later. So just a picture from books. So this is transform. You see it is straight. Remember, yeah, this is unsaturated, but it is straight, i.e. it's like saturated fatty acids. Meaning, it's not that good for health. Okay, so there's no bending. I was mentioning the hydrogen here and hydrogen here. They are on either side of the double bond. Was compared to the cis form. See, the hydrogen is on the same side, and they are bended, so they are more like the unsaturated fatty acids. So what we learned today. Bending is good for health. Straight, good for technological function maybe. That's why people in industry love to do trans fatty acids or trans fat. Okay, this is just comparison, the final slide for today. Cis and trans fatty acids and their relation with the melting point of this particular fat. Yeah. Okay, fatty acid name is stearic. This is just comparison. Saturated fatty acid, similar carbon number C18, and then we have unsaturated cis oleic and trans unsaturated or allydics. Yeah. See, by forming trans fatty acid, see the changes in the double bond and the melting point. Sorry, and basically the number of carbon is the same. And the number of double bond is the same, 1 and 1, but because you change from cis to trans, you change the melting point. Okay, so we learned today, as we learned before, the melting point of saturated fat is higher than for unsaturated fat or fatty acids. That's established. Number 2, we learned the trans configuration down here, down there. Results in higher melting point than the cis. What I didn't didn't show you just now is that most cases fatty acid exists in food is in the cis rather than in trans configurations. Yeah, it is when you process it becomes trans. And then finally, because it is oleic, is a cis, the melting point is lower. It is more of a liquid-like versus compared to allydic. It is now a solid in terms of state or condition in the room temperature. Okay, so for food lipids, the thing for food technologists have to learn basic is that the structure of the fatty acids and how it is related to the whole fats, and the structure of the fat, how we form the triglyceride by combining 3 fatty acids to 1 glycerol with the liberation of 3 molecules of water and formation of the ester bonds. And then we learn between saturated versus unsaturated fatty acid, and how this can also become saturated and unsaturated fats. And then we touch a little bit about the cis and trans fatty acid configurations and how this can affect our food, our fat when they are used in food later on. Okay guys, so I'll meet you again in part 2 of fat as food component. For now, happy learning.